Okay, welcome everyone. So today we are going to handle our very first lesson on iterative methods. Yes. So we need to know what iterative methods are before we can proceed with anything. Yes. So I'll give you a simple introduction so that you know how everything looks like. Introduction. It's very brief. So I'll begin with the word iterations. Of course, you will need the English meaning before we go to even the mathematical one. So basically, iterations in according to English, it means repetitions. Repetitions. Yeah. Provided you're doing something repeatedly, it is repetitions. But what are you doing all these repetitions? You're doing all these repetitions to get what you want. Of course, in mathematics, what do we want? We want truths. So these repetitions in real life can be adjustments. The only example I have will only work for the unplanned kids. The planned kids may not relate. But if I may ask, have you guys ever, I don't know, that's how we used to draw a radio in primary. We used to come here and draw a very big circle. Then we put something like that. Then we come here and draw a smaller one like that. That's how we used to draw a radio in primary. Then you all know that this is the volume button, if I may say. Do you guys recall that we used to move it like this? I think like this used to increase volume, isn't it? The unplanned kids can confirm with us. Then in that direction we used to decrease volume, isn't it? Am I right? I think I'm right because I'm part of the unplanned kids. Is it true? Yeah, it's our time to shine and people are confirming. Yeah, very true. That is it. Increasing volume, then reducing volume. So what you were doing, or what some of you even still do, is what we call an iteration. You're trying to adjust the volume repeatedly until you get what you want. You keep adjusting and adjusting. You increase Carito, you decrease more, you increase Carito until you reach where you feel like you want. That's what we are going to be doing in math. We are going to just keep adjusting, doing a lot of repetitions until we get what we want. So that's a real life example I can give you. So those repetitions we are doing in adjusting volume to get what you really wanted, it's a form of iterations. Now, when I say iterative method, the method you're using to get what you want, the method you're using to do your adjustments so that you get what you want. So just English, iterations, iterative method, nothing much. So you need to know the iterative methods in this topic, how many they are, and how the topic is broken down, and how we are supposed to do what to follow everything up. So I think I'll leave that example of mine, or I may remove it. But I've said this one happens in real life. In real life. Yeah. Those are iterations in real life. So let me show you what the syllabus book says. What the syllabus book says, so that we can have our lesson targets and then proceed. So we are going to look at syllabus. Yeah. So I don't know if there are people who looked at our course outline and try to notice which topic our iterations are. I don't think so, but I think they're just here. Topic 22, 23. Okay, they're here. 23. So it is topic 23. Those who may want to know the class, so don't be surprised if you covered them first. It is a topic of senior 6 term 2, if I'm not mistaken. Yeah, senior 6 term 2, according to the syllabus. But of course, it is something you can cover in term 1 and students understand. Okay, now, the very first subtopic is linear interpolation and extrapolation. Then the next one is root location for strictly f of x equal to 0. Then the last one is Newton-Raphson method and further linear interpolation. So this one I'm not doing anything in subtopic 3 and 4. I don't know if you can see that I combine 3 and 4. Yeah, this is my own syllabus book that I never give out unless you take some screenshots. You see, it's even having some advice to me that I'm not going to follow because I gave it to myself. Okay, and the topic will be done. So, 3 and 4, I'm not going to talk about anything there today. For today, this is what we are going to cover. I want us to review the gradient method as far as the syllabus is asking. I want us to do the experiment, you get, and talk about it, of course, and also do some numbers, you get. Doing the numbers, this part you're seeing of predicting the non-tabular values, meaning the values that are not within the table, yeah, and those that are outside, you get. Then they want us to look at the root location for f of x. For us, we shall there are so many alternatives of locating roots, and we shall look at one. So I think if we are serious, we shall need around 3 lessons or 4 to perfect this, and we have 5 weeks. So I believe we are safe. Those who will be listening to this in the future, maybe the lessons will be done, and your role will just be to cover this. Hope you people have seen the program and the plan for today. So I'll go back and write our lesson targets. Where are we? We are here, I think. So I'm going to come and say lesson targets. More than 100 people are here just to learn linear interpolation. You people are not serious. You're not reading. Linear interpolation, the easiest topic in high school. Okay. Lesson targets. So the very first one is of course reviewing gradients or reviewing the gradient formula. Okay. Yeah. We are going to look at all cases. We are going to look at all cases. All cases. We are going to look at all cases of these two. All cases of linear interpolation. All cases of linear extrapolation. Just like that. Then a 3 shall introduce. I think we are going to do like last time. We shall rest a bit, then we get back for root location. So we shall look at all cases of linear interpolation, extrapolation. Then after they are done, we shall pause a bit, break for 10 minutes or 15, we get back for root location. Yes, I know some of you never come back, but that's of course a mindset. Okay, so that will be the end. Nothing much. Okay, now let me ask you something simple, and I would want you guys to tell me in the chat. For me, I'm going to tell you the meaning of I'm going to tell you the meaning of the rest of the words. I just want you people to tell me the meaning of only one word, and that is the word linear only. Who knows the meaning of linear? The word linear alone. Okay, that's good, that's good, that's good, that's good. Yeah, people are talking of a straight line and so on and so forth. That is good, that is good. Anything to do with a straight line. People are talking of acting in a straight line as if we are talking about forces. Okay, so this is linear int. Edit it later. Okay, now you listen up, listen up. So linear interpolation and extrapolation. Let's first understand what they are really talking about. Someone may be like, why do we really, why do we really talk about gradients and so on? So linear inter, or we can say extrapolation. Yeah. So when they say inter or extra, I'll explain later, but I'm interested with the linear thing. So by linear, you all know we are simply meaning a straight line, straight line, straight line. Yeah, simple as that. So you all know that what do you know about a straight line? I can have something like this. You all know that if we are on a Cartesian plane, this is a value of y, this is a value of x. A straight line is that. And you all know you don't just do it for, it's always having points. You can have a point here, you can have a point here, you can have a point here, you can have a point here. So those people who studied with me-scatter diagrams, you can understand. Remember how we are coming up with the line of best fit, and it also had points at different levels or points of the line. You get? So that's what they call a line. That's what they call a line. So how do questions come, and what do they always want us to do? So, and before we even go any further, what is that thing that is so special about lines? You know, lines are, they call them steep lines, straight lines, horizontal lines, vertical lines, you get. And we all know that the vertical lines, I don't know whether you people know their gradient. We also have the horizontal lines. I don't know if you people know their gradient. We have the lines of different slope, and slope is what they call gradient. So one basic character of lines is what they call slope or gradient. And every time lines are talked about, the only defining factor they have is the gradient, so you should respect it. So the question may be, how is this gradient really going to help us in this topic, and why is it coming up? It's coming up because at this point, you know that this point has a value of x, we can call it x1, and a value of y, we can call it y1, because they are different, x1, y1. You get? Even this one, it may have x value x2 and the y value y2. You get? Even this one can have the x value x3 and the y value y3. Same thing here, x4, like that. If at all you want to show, I think that is obvious. This would be the x2, this would be the y2, that. This would be the x3, this would be the y3, and so on and so forth. So why a line should come in is that whatever we are going to deal with in this topic, it will of course be x values and y values. We need their relationship, and because we are dealing with a line, their relationship can only and only be brought together by a line, because it is a line that is bringing those points all together and nothing else. So you need to know, in whatever you're doing, in whatever you're dealing with in this topic, make sure that you know the gradient formula. So I want people to tell me, considering that line that we have, I can come here and call it line AB. I can say this is our point A. I can say this is our point B. I want people to tell me the formula of gradient for that line. And as you're raising up your hand to come and tell us your stories, please tell us whether the formula is one or there are many. And if there are many, I want you to state all of them, not only one. And if you state all, trust me, for you will understand, what they call linear interpolation and extrapolation. So before we even proceed, you all know that before we plot these values, we are always having a table. Yes, for the values of x and values of y. As you can see, x1, y1, reserve, x2, y2, x3, y3. You people, I'm not going to use, I know some of you want me to use values, but I'm not going to use values. I don't know, have really people forgotten gradient, something I taught myself in coordinate geometry? You people, you want to tell me that you cannot get gradient from that? You cannot get gradient from that? Okay, who knows the general formula of gradient? I think I can remove these ones. They are making a diagram dirtier. Who knows the general formula of gradient? Okay, tell me only the general formula of gradient, then I'll do the rest. Yes, Fahad.
It is change in y, change in y over change in x.
Change in y over change in x.
Change in y values over
Okay, thank you for that try. So gradient of line AB. You people know that if I give you your values, you can really calculate. But what you really need to know is that the gradient of line AB, it will be just change, you all know, change in y over change in x. And I want someone to remind me. This is the general formula. I want someone to remind me which letter in mathematics is used to denote gradient. Which formula in mathematics is used to denote gradient? Yeah, you people know it, but most of you are failing because you're giving. Someone is even saying letter G. May thunder fire you. It's M, but most of you are writing capital M, which is not right. Which is not right at all. It is not right at all. So you people, you look here. If I'm to consider only 2 points, if I'm to consider only x1, but you people, you've forgotten the basics I gave you. You're forgetting the basics I gave you, and I'm going to show you that you forgot. Let us first answer this question. Look here. You see, this linear interpolation is confusing if you just want to cram how questions are done. There are questions that will come and you will not be in position to reason, which will be very bad. So if I'm considering only 2 points, that is x1, y1, then x2, y2. Are you listening? Which one of these two is correct? Yes, for gradient. For gradient. Of course, we are talking of gradient. Of course. Maybe I can put here M. Have the first one and second one. The first one I'm calling it A. The next one I'm calling it B. Which one is the right one? When you say that A is the right one, that means you're saying that B is wrong. So you either say both are wrong, A is correct, B is correct, or both are correct. Yes. Which one is the formula of gradient? M. People are saying B, people are saying B. You people, all of you are saying B. What is wrong with A? What's wrong with A? You people, both are correct. Both are correct. Those who are saying B, stop it. Both are correct, and that's why I think you see why I'm investing a lot of time in the introduction. I think you can see why I'm investing a lot of time in the introduction. Both are correct. What makes both of them correct? I remember in that lesson I showed you that you get the same answer. Provided this is 1 and this is 1. Provided this is 2 and this is 2. And then also this side, this is 2 and this is 2. Even this is 1 and this is 1. Provided you do that. And it is changing Y. This one is correct, then this one is correct. Provided you help us with one thing and say that we are dealing with change in Y over change in X. If you do that, we don't mind about the order. But when you begin with y1, let it be x1 below. If you're beginning with y2, let it be x2 below. That is it. Let me write here a wrong formula very fast, then I remove it. If you say y2 minus y1, but down you say x1 minus x2. Now this one is wrong because of 2 and 1. But I just don't want to write a lot of wrong answers on the screen. I think that is clear. I think that is what? That is clear. That is clear. Now, after you guys understanding the formula, I want you to go back to that line. Have it in mind that there are 4 points. There are 4 points, and we need gradient. They're in a straight line. Have it in mind that gradient can be obtained by any of the 2 points. Any of the 2 points. Any of the 2 points. So in the sketch, we are having the gradient or slope can be obtained by any of the 2 points. Can be obtained by any of the 2 points. Any of the 2 points like that. Yes. I'm also going to show people a certain technique. You see, this mathematics is funny. Very funny, very funny. I'm going to show you a certain formula and people are going to be shocked. Before I proceed, who can give me all the formulae of gradient that are on that line of AB? Okay, let me give you a few, then you give me others. Because seems people are not getting what I want. So if I need the gradient, small m, strictly small m. If I need the gradient of AB, I can say, let me consider x1, y1 with x4, y4. That means I will say y4 minus y1 out of x4 minus x1, isn't it? Or I may say, let me consider y2 and y3. And I say y3 minus y2, any 2 points, then x3 minus x2, provided they are corresponding. That's all I want. So who can get us others? Let me pinch the screen a bit. Who can give me more 2 formulae? Who can give me more 2? I need more 2 only. You pick any 2 points. Any 2 points. Yes, evidence. Now your hand is down. Yes, acrod.
Yes. Other two points. I can
Mm,
consider
mm.
y2 minus y1 divided
You first leave that. Let's first use the other direction.
I can
You may
consider
leave.
y5
Why what?
y5 y5
I don't have
minus y
5. You first leave the 5. Okay. Okay, it's okay. Y5 minus.
minus y4
Mm,
divided by x5 minus x4.
it's okay.
Or
Yes,
I can
secret.
say
Yes, acrod. Complete and give us all of them.
y5 minus y3 divided by x5 divided by x3.
Okay, that is good. So people, that is it. But according to what acrod has been giving us, he has been following the direction I chose. You get the point? Now, I want to ask people, if we are saying y4 minus y1, y3 minus y2, you've heard him say y5 minus y what, like that. I have a simple question for us all. So yeah, he has said that you can say y4 minus y2 over x4 minus x2. Said you can say y5 minus y3 over x5 minus x3. But you all know, even the y2 minus y1 works. Shouldn't forget that basic one. And so many others. It is the same line. So realize we are using 5 minus 4, 4 minus 3, 3 minus 2, like that. So according to what you guys are saying, which direction are we following? Because in this topic of linear interpolation, the direction you're following matters. People tell me, if I say y4 minus y1, or if I say x4 minus x1, am I following this direction in red, or I'm following this direction in blue? You tell me, is it red or blue? If I say x4 minus x1 or y4 minus y1, am I following this direction in red, or I'm following the direction in blue? Because if you don't understand which direction you're taking, you cannot pass this topic. So which direction are you taking when you say x4 minus x1? You people know math. You people know math. You're following the one in blue. Exactly. On point. So all these ones that we are having, are those of this direction. Yes. But remember, this is applied math. A lot of things are in applied math. It is the hardest branch, or the harder branch of math. Yes. But we can also have the other direction, this one. So in this direction, that's where we say, if we're following that direction, that's when you say x1 minus x2, like that. So all that, now let's change our minds and say the gradient of the line AB. To show that it is a line, you can just put a line on top like that. So here you just say y1 minus y4, and I told you it is the same thing. y1 minus y4 over x1 minus x4. Then you come here and we are just changing direction. y2 minus y3 over x2 minus x3, following the other opposite direction. Then y2 minus y4, then x2 minus x4, y3 minus y5, then x3 minus x5, y1 minus y2, then x1 minus x2, like that. That is considering that direction. So after you people understanding that, so you choose any, and we are going to see how these things are applied. Now, it's not a must that you use left to right or right to left. You choose any that you want. Now, I want to show you people magic. So let's assume I pick this out. Are you seeing this portion? This one. Assuming I pick that portion out. And when I push that portion out, I cross multiply. I want you to follow critically. Think, let me say, please turn over. Please turn over. Are you seeing the thing I'm pulling out? It is 1 and 4, then 2 and 3. 1 and 4, 2 and 3. So I come and say, pull that out. It is 1 and 4. So y1 minus y4 over x1 minus x4, then 2 and 3. y2 minus y3 over x2 minus x3. That's what I'm pulling out. I don't know if you can realize. Are we together? Okay, now let's cross multiply. This is chicken math. So I'll come and say, y1 minus y4 multiplied by x2 minus x3. Then this side I will have y2 minus y3. Then I will have x1 minus x4, like that. I want you to follow. Now I'm going to do something funny. Hey. I'm going to bring this. Are you seeing this? I'm going to bring it this side. Are you following? Then I'll bring this and I'll take it the other side. It will cross the equal sign. Are you following? That is 1. Then 1, I'll come up with a new formula. I'll come up with a new formula. And what is this formula going to be? This formula is going to be x2 minus x3 over what I'm bringing this side is y2 minus y3 equals, then the other side I will have x1 minus x4 remaining, and what am I taking the other side? Of course, this one won't be plus or minus. It is multiplication, so as it crosses, it becomes divide by. So down it becomes y this minus. So I want people to tell me that new formula understood. Because now what is that? What have I done? Nothing. Is the new formula okay? I don't want you people to say that doctor told us that gradient can also be changing x over changing y. No, that's not what I've said. But when I play with the formula of gradient, but after equating two functions, I realize change in y over change in x equaling to change in y over change in x is the same as change in x over change in y equal to change in x over change in y. You get the point? The mathematics remains the same. Oh, okay. Now, another problem. I'm going to rewrite this step, yeah? This step, that one. So I'm going to rewrite it. I'm going to rewrite that step. Then I show you another weird thing to do. Hey. And what is that? Hey. You people, you are joking. That formula has been y1 minus y4, then x2 minus x3. Now, this is what they call literal math. Math that is full of literature, but we have not said any calculations. There is a group of students that can understand this math and fail to understand calculations. There are students who just understand calculations without even necessarily understanding this, which is very okay. There are those who understand both. Those who never understand both do not exist. Yes. So if you're there and both refused, please doubt your existence. y2 minus y3, then last we have x1 minus x4. This is what they call appreciating the beauty of math. Okay, now after that I will come. I'm going to also do something funny. And what is that? Someone is like, what's funny yet I'm not understanding? I'm sorry. So I'm going to get the ones of y, I put them on one side. Then I also get this one of x, and I also take it the other side. So that I have y alone, and I also have x what? Alone. So what will I produce? Someone is now writing in my screen. I don't know. Okay, so what will I have this side? I will have y1. So we are having a new formula. Yeah. y1 minus y4 over what? y2 minus y3. What do I get? I get x1 minus x4 over, what do I have? x2 minus x3. Another new formula. I don't know if people think it. So when you look at this new formula, don't say that doctor said that change in x over change in x is also gradient. No. But when I played with the real gradient function, I came to realize that when I have change in y over change in y and equate to change in x over change in x, I'm still very safe. So there are a lot of things that you're going to see in this topic. You will see the gradient function being played with. You're going to see what I mean. But these are things we use to do linear interpolation. But I don't mean that the gradient can be obtained using the same methods. No, the gradient formula doesn't change. Change in x over change in y. These other things are just coming in after. They are coming in when after I've tried to play with it. And then I realize, oh, different things can come up. So realize if it changes from x, if it changes from change in y over change in x to change in x on top, this is the only thing you require. Provided this is a 2 and a 2, this is a 3 and a 3. Change in x over change in y can work. Provided this is a 1 and this is a 1, this is a 4 and this is a 4. It can work. Then this one that has y's on one side and x's on one side, same thing. Provided it is it is 1 and 4 on top, 1 and 4 on top. Then down it is 2 and 3, 2 and 3. I don't want you to be like, hey, doctor, why isn't it the same as the ones before? Remember, for the ones before, it has been either X or Y down or up. But for this time round, it is only Y on one side and X on one side. But this is math full of literature. You're going to see when it comes to calculations. I told you what do calculations do? They bring it out very well. But as of now, I'm giving you prophecy, which we are going to find ahead, trying to show you that in case we are applying everything, when I change the formula a bit, just now I've changed nothing. The mathematics doesn't change. It is constant. It is what? Constant. So what are the things to note? What are the things to note? Let's note the three as we hear from evidence. Yes, evidence.
I need screenshot.
Yes?
Screenshots.
And madam screenshot. Okay, let me finish this, then we take the two. Because I think we so far have only 2 or 3. Okay, now what is the first note? This is it. Change in y over change in x equaling to change in y over change in x. Yeah. Then the other one we found, the next formula it was having change in x, change in y, and also this side change in x, change in y. Then the other third formula that we found was change in y, even down change in y. Then this side we had change in x and change in x. Someone may be like, don't these things change? Like, don't they cancel? And then you remain with only one, no? Don't worry. I think you know what I mean. So I just want to tell you that any of them can work in a calculation. Any can be used. Any can be used in a calculation, as we are going to see. Any can be used in a calculation. Any can be used in a calculation. Provided this direction or this direction is considered. What you people call considered. Provided you consider the directions, then you can choose any that you want. We are about to start calculating. Let me complete my stories in peace. For me, I have time. I don't mind about you. Okay, now, yeah. What is the other important information? So you people know that linear, because of the word linear, straight lines. Because of straight lines, their guy is gradient. We have seen how gradient can be determined and how picking a section from all formulae can try to bring new formats that we've not heard of before. Now, back to what the topic says. The topic says linear interpolation and extrapolation. So it is inter and extra, but epolation is a constant. So you can ask the internet, what is epolation? And you tell me in the chat. Inter and extra, both are the different words they're the ones accompanying the word epolation. So as evidence, takes the screenshots, go to the internet and ask it, what is the meaning of the word epolation? Then you tell me, after getting nothing from the internet. For you think the internet knows everything. That is screenshot 1. Hope you're done. Then let's get screenshot 2. Now someone is writing in our screen. I don't know why some of you are just like that. People keep writing on my screen. Please stop it. We shall organize a session where we shall come here to exhibit primitivity. And then we shall see who make the screen dirtier. Then this is the last screenshot. Yeah. You people, you go and ask the internet, what is the meaning of population? Population. So linear, inter, yeah, people are giving me answers in the chat. Where are you getting them from? Oh, okay. So let me give you my local meaning. So population alone, locally means estimating unknown values. You get? Then inter means between known values, understanding. Then extra means outside. Some of you are biologists. You know that what they call the intercellular space is that space between cells because of intercellular. And you know what they call the extracellular matrix or the extracellular fluid is that fluid that is outside cells. Then when they say intracellular fluid is that fluid within the cells, the cytoplasm and its cytosol making up the protoplasm or protoplast. So that is outside known values. You get? Then linear. By linear, we say that here we shall be using gradient functions. Using gradient functions. Now I want that person who is good at back titration to define for us these things in the backward way, because we move like that. We move like that. So we either move from here to here, you get the point? Then also this one about the meaning, we either move from here to here, or we move from here to here. Get the point? Then you also move from here to here, depending on what we are defining. So we can use those arrows and define for us both linear interpolation and extrapolation. Hey, who is ready? But your definition should begin with locally estimating. Please, people, be fast. I just want one person. Define both using what you're seeing on the screen. Just follow how arrows are moving and we go. Yes, Fahad. Define both.
For interpolation, it means estimating unknown values between known values
Fahad, a
using.
moment.
Yes.
Are you a Munyankole?
No.
Oh, and I had heard you say
No.
interpolation. Hey, okay, it's okay. And I heard you saying interpolation. But okay, you can proceed. Define both.
For interpolation, means estimating unknown values between known values using gradient functions.
Then extrapolation.
It means estimating unknown values outside known values using gradient functions.
Exactly. Yeah. Then for you are going to enjoy the topic. And that is all. So straight away, I'm not going to waste a lot of time. I'm going to have the very first questions. And I think I'm going to get my questions first from my from that document I used years back. Yeah. So we are going to see how things are done. Yeah. Okay. Okay. Yeah, this was back then. This was back then. This is one of the schools that won a lot of academic awards. I still have these documents if you need them. But they were questions of old curriculum, but of course you need them to master the content. This was group assignment 002, and I set it, I think it was in June of 2018. And I remember these group assignments, I think they go up to 817. Yeah, so many. Okay, and they are always very short. Yeah, so I want us to first go through these questions very fast. I'm giving you 2 minutes. I want to see if you people know how to round off and whether you people know how to truncate. You write the answers to this and whether people know what significant figures are and DPs. Just get for me those 5 marks. You round off to those required DPs, required significant figures, or what we call the required levels of accuracy. Or someone raise up your hand. You speak them, we go. Don't stop on rounding off. Make sure you can also truncate. Where is Judith? Judith, let me check. Mhm. I'm seeing only one Judith. I'm looking for Judith N. What is Judith N? Who can unmute? Okay, tell us on your rounding off. Then me, I said I give you truncating. Anyone to do rounding off only, then me, I truncate. Teamwork. Yes, Gilbert.
Yes, good afternoon, doctor. Good afternoon, fellow students.
Which country are you?
I'm from South Sudan.
Oh,
Yeah.
so that side it is afternoon, eh?
sorry.
Oh,
It's evening. Eh?
I thought. I knew. Why do you drink and talk?
No, I don't drink.
Okay.
So I'm going to do the round off. I'm starting with Roman numeral 1. Yeah, it is 2.781.
That is very good.
And then the second one is 0.051.
0 point.
0.0
5.
5 5 1 1.
Not 10. It is 10, not so?
Yeah, it's like that.
You are lying. It is 0 1. Not so. Like this 0 1. Because these zeros, these ones are not significant, isn't it?
Yeah.
But the moment a non-zero comes in, all the others are significant. So those are the 3 significant figures. And we use the calculator. We proceed.
Then the other one is 109 point 0.00.
0.00. But if you are in an exam, you can just leave it as 109 because 0.00 is nothing. Do you know how to truncate? Do you know
No,
how to truncate?
not really.
Who knows how to truncate? think Engineer Josh knows. Yes, Josh, you tell us what truncating means, then you tell us.
Yes, good evening, Doctor and other guys.
Mm,
Truncate, it
mm.
means you, what can I say? You write the exact,
You cut, not so you
correct,
simply cut without rounding off, not
yes,
so?
you cut. Yes, you cut.
Without
You don't
rounding
round
off.
off, you don't do anything.
You just
You
cut.
just cut, yes.
Yeah. So when they say this one to do deep is, how will the answer be?
0 point,
0 point.
0.08.
Exactly. Hope you people are getting it. Eh? So with the truncating, you just cut without rounding off. So you come here where 2 deep is, you cut. You just write what you see. Don't say that 8 will make 8, 9. No. Truncating, just cut and don't round off. Period. Then this one of significant figures. What is the answer?
5.008.
Wait. Let people write the final answer in the chat. You people truncate for me the last one, because that's the last value. So truncate it on your own, then we proceed. All of you truncate. Hey, by the way, someone is saying they are not contented with Roman. To your right, it is that bearded person who was confusing me. I first wrote 1-0, then he confused. It is 1-0. Hey, 1-0. That is the answer. 1-0. I think now you're contented, Richie and Judith. Do people have the correct answer of truncating? Truncating 5 significant figures. Hope Judith and Richie, you're now contented. So 5 significant figures, we shall count them. This is 1, 2, 3, 4, 5. Then we cut, so it will remain 7. 0, 0, 8, 7. Yeah, that's what truncating means. Yeah. So when you find it anywhere, you're now aware. Okay. Now, this thing to do with the percentage error, this one I taught errors myself. So you do it in your free time. You refer to lesson 1 of error analysis. Error analysis, which is topic 16, senior 5, term 3. Yeah. You can take that screenshot and show it to friends. I've given you the directions. Topic 16, the very first one in senior 5, term 3, error analysis. Then this one, the same topic. Topic 16, you can even easily find it on the drive. It was also errors, but I think this one, either lesson 1 or 2 can help, whichever you want. You can go to lesson 1 if you want first principles. You can go to lesson 2 if you want to use error propagation. It can help because it is error in addition. Yeah? Okay, now this one 4. This one 4 is now what talks about linear interpolation or extrapolation. This is what I'm going to begin with. Then we shall go to the next thing. So that's the number I want us to first do. Remember, we drew a table which had x values and y values. So this time round, we are having x values and values of f of x. And you all know from differentiation, you all know that y is the same as f of x. Because when they say y is x squared, I can come and say the function in x is x squared. That means y and f of x are the same. So don't overthink. They usually give you that. However, they can change. They can change the trends, as we are going to see. Yeah. So let me show you how. How? these questions come. That's how questions come. That's how questions come. That's why they always look like. They will tell you given the table below, as you can see. Then they will give you the first row with values of x, then the second row with values of f of x or y. Then they will tell you use linear interpolation or extrapolation. They will not tell you which one to use unless you're using the same for both Romans. If you're using interpolation for Roman 1 and 2, they can say use linear interpolation. If you're using extrapolation only for both, they can say use linear extrapolation. But in most cases, they leave you with an option of choosing for yourself, whether you're using interpolation or linear or extrapolation, like that. So look here, they are saying that find x when f of x is 2.17, when it is 2.178, you get. So they gave you the values of x and they are increasing 9, 10, 11, 12. Then they gave you the values of f of x that are decreasing, you get. They gave you this, and this. And those of you studied with me scatter diagrams and correlations, you can tell that that is a negative correlation. I told you that. X is increasing, but f of x is decreasing. But don't focus on that already. Let me first hear from Evans. Yes, Evans. You people, I want you to listen to each and every statement. I don't want to leave anyone behind. With this topic, you understand the first example, you've understood the whole topic. Yes.
Excuse me, sir. Good evening, sir. So I'm asking, like, how do you separate both linear interpolation and extrapolation? How do you separate them?
Have you just joined?
No, but I've not
Do you
understood
remember
some.
when? Okay, this is what we said. Fahad tried to define, and we said that assume that polation alone means we are estimating unknown values, because you can even see they are telling us to find x. That means it is unknown. And when they
Yes.
say inter, for inter, it is always between known values. Then for extra, it's always outside the known values. And why linear? It's because you are going to use the concept of gradient functions. You
Okay.
get?
Yeah.
Yeah, that is it. So you're going to see this very first example and it will relate very well. So you put that is it. So I'm posing my question. They are telling us to find the value of x. I want you to listen to how these 3 marks are obtained. I want you to listen extra carefully. How those 3 marks are what? Are obtained. Now, f of x, they are telling you to find x when f of x is this. Who can tell me where this value of f of x is? Is it outside this table? So when it's outside this table, that's what they call. If it's outside this table, what you'll use is linear extrapolation. But if that value is somewhere in between any of these values, that's what they call linear interpolation. So you people tell me, is that value between the known values or outside? If it is outside, on which side? The left, the right? If it is within, between which 2 known values? That's all you need. That is all you need. And let me hear from Saida, because I think she put the hand up first. Yes, Saida.
Good evening, sir. I think what I'm seeing, that number of x, f of x is in between, so it is interpolation.
What have you said? I want you to make correct statements. For me, I hate wrong statements in my life, especially if I have explained very well. You repeat, what have you said?
The f of x that I've given to us, it is 2.17. It's going to be in between 2.42 and 2.18, so it is interpolation.
It is between? That's where I
Two,
want only. It is between what?
it is between 2.42 and 2.18.
That is true. Meaning we are going to use linear interpolation also.
Yes, sir.
Thank you so much. Thank you so much. Thank you so much. Thank you so much. So people, that is it. And when you realize that you've passed, the moment you realize that what you're looking for is here, and now we know that you're going to use linear interpolation, you've passed. So you're going to come and draw the table. So this is what we always do. You draw the table. You draw the table. Are you listening? This table is always having 2 rows and 3 columns. I'm going to tell you why. Remember, it is between, yeah? It is between. And since it is between, that means there are values on the sides, the known values. Remember, we said for interpolation, the value we are looking for is between known values. So what is the best thing to do here? Okay, you may not waste your time to put here x and f of x. You may not do that. You are wasting time because we already have the format x on top and f of x down. But there are people who include it, but you may not need them. So you come and say, the value I'm looking for, or the value I've been given is 2.1789. And they want me to get the x value when f of x is that. So you ask yourself, what are those values on the sides? So the values on the sides are these ones. These ones. So you come and put them. You come and put 10 here. Then you put 2.42 here. Then you also come this side. You put the 11. And then you also put the what? The 2.18, like that. Mere doing that, mere allocation of that value, you get a bonus score according to the old curriculum. Bonus mark. Provided you locate that value correctly, you get your bonus mark straight away. Then the next mark is now you using the gradient stuff. The gradient stuff. Correctly, and I'm going to show you how. To take you back a bit, I will give you some sort of advice. And I want you to listen carefully. What is the advice? The advice is simple. That when substituting in the gradient functions, come on, say. And what are those 3 things? So you listen to them carefully. I don't want you to say, I didn't tell you. What are those 3 things? The first one, maintain your direction. So maintain that one or this. Maintain either the left, right, or the right to left. Maintain it. Then 2, remember, we always be like maybe, let me use alphabets, letters of the alphabet. We always say A minus B, C minus D. On this side, we can use maybe S minus T, then U minus V. So this is the rule. The rule is simple. On this side, this is the position. So this is it. The unknown should always take up that position. Hope you people are noting this word always. Should always take up that position. Should always take up that what? That position. If yours has been occupying or taking up any other position, you cry. Then what is the other? We are still on that. Three things, eh? This is the second. This is the second note. Then the third note. 3. S, T, U, and V should be purely known values. Should be purely known values. Should be purely known what? Known values. You get? So this side, which is the left, is the one that will have the unknown. And then unknown should take up this very first position. Then this side should be the known side. So whatever is on that known side should purely be a known value. So this side of the right, we don't expect any unknown. Then this side, the left, we only expect one unknown, which unknown should always take that position. Of course, apart from a few cases which don't even come, they have never been set. But I personally set it and it is in that document. But you also see it's not a big deal. It's not a big deal. So that is the simple rule, and it's what we are supposed to follow. It's what we are supposed to follow. So someone may be like, why are we really doing this? Why are we considering the unknown to take only that position? I'll come and tell you that such that. Why are we really making the A only to be the unknown? Such that, if we are to get the A, I don't know whether you people are seeing this. I want you to look here. Do you people realize that if you're to get the A, this is what you do? You get the S minus T, then you multiply it by the C minus D. You know that passing that. Then you divide this by the U minus V. You get? Then after you add B. Are you people seeing that? You people, you tell me, do you see that? Is it correct? That if at all our unknown always occupies that very first position, do you see that if we are to press it in the calculator, we can get everything at once? We get this S minus T. Remember, this can be, you can do some sort of cross multiplying and that one goes there. You multiply it by the C minus D. After now, you can divide by the U minus V. Then after, you can bring this negative B and then take it the other side as a positive. I don't know if people are seeing that. So with that, we'll have obtained this unknown value. This is our unknown. And why I'm giving you this, that you can press it in the calculator at once without wasting time. So this one can be pressed in the calculator at once. Can be pressed in the calculator at once. Can be pressed at in the calculator at once. You people, is that okay? Because now when we begin calculating, I don't expect any questions. Because now I've given you the advice. And that is the full advice. You need to do all calculations. Maintain the direction you're using, whether left, right, or right to left. Let the unknown occupy the very first position, depending on whichever direction you have used, whichever format. Let the left-hand side have the one unknown at the appropriate position, and let the right-hand side have the known, be the known side with only and only known values. When the unknown takes up that position I've told you, it will be very easy for you to obtain it by taking all the rest of the things on one side, of which you can even press in the calculator at once and get the answer. a correct one without struggling. You get? And you people, the topic is done. The topic is done. Yes. Okay. Now, let's go back here. And I ask people what to do. Now, let's say you're choosing, so you've chosen your worker table. I told you can remove this and only have the table. It is very okay. The mere fact they are saying X there, they will know that the first column, the first row is the row of X values. So you people, which direction can we take? Which direction can we take? The problem is that when you take this direction, let me now brief you for the first time. When you take this direction, you will have something like 10 minus 11, which is a negative. But you will have this minus this, which will be a positive. You get? But when you do the reverse, and maybe take the other direction, maybe this one, this, you'll have values like 11 minus 10, which is a what? A positive. Then we'll have other values like 2.18 minus 2.42, which is a negative. So you realize that either directions, you have no escape route, like you can't escape a negative. So you take on the direction you really want. So let's say you people have chosen this direction like that. Yeah. And then you've said that now we can begin the math. But remember, the first value you're writing should be, the first value you're writing should be, the first, I repeat, the first value you write should be the unknown. So the unknown is X. So I'll come and write X first. You get? Then I ask myself, which direction are we taking? This direction. Then I'll say X minus 11. That is the only option. After saying X minus 11, then I'll come and consider the very Y values down. Remember, as we are calculating, I said, whether it is changing X over changing Y, no problem, provided you maintain that. Then down, what will I have? I will have 2.1789 minus 2.18. And that is done. Then this side, we should purely and purely have known values. Since we should purely and purely have known values, what does that imply? That we are supposed to use this column and this column. But as we use those two columns, we should respect the direction that we did what? We chose. So because of that direction we chose, this side we shall have 10 minus 11 on top, because even on top we had, on top we are having X, then down we are having Y. And this side should purely have known stuff. So I'll come and write my what? Come and write my 10 minus 11 like that. Out of exactly what is the value under 10? 2.4. So I come and write it. What is the value under 11? 2.18. I come and write it. So now there you've applied the gradient function, and here you get a method mark using the gradient function. That was according to the curricula. That's how marks were awarded. So after that step, they expected the student to come and just write the final answer. Final answer. And here they didn't tell you to record it to any decimal place. So the minimum would be 4. But you know me in math, I write 5 because the minimum is 4. Then in physics, you know what we do. So I want you people to use the calculator. How? You get your calculators and press brackets. You put that inside. You multiply, you bring brackets and do that 10 minus 11. Yes, you know it is -1, but next time it will not be -1. It will be other values. So you practice. Put this in brackets like that. Multiply it by, even if you don't put the multiplication sign, and just do this. You put just brackets. After, you can now divide and also put this in what? In brackets. And then after that, you add 11 and get the answer at once. If you want, you can break them down. You keep having like answer, then times, answer, then but you can put it in the calculator at once and get the overall answer. I don't know if anyone has been left behind as far as coming up with the table is concerned, coming up with the gradient function is concerned, and pressing it in the calculator at once to get the final answer is concerned. I don't know. Do we have the answer, people? Do we have the answer? I'm going to check my guide if you people don't want to give me the answer. Yes, have my guide here. See, I organized it long ago. Let me hope we passed those things. Yeah, this was my guide long ago. I think we passed those ones. Yes, we even rejected some parts. Yes, the answer for error was there, even that for absolute, so we are here. This is the number where we had. Do you people have that answer? For me, I've never left 5 DPs since 2017. I don't know if you guys were born. That's where we are. I think you can see. Very clear instructions that you get a bonus mark the moment you identify the unknown x value tabularly. Then you get the method mark 1. You see here I considered this direction, yeah? From right to left, but first we have considered left what? Left right. And then you get the final answer mark for the output. Then the answer to 4 DPs is accepted, but to 3 DPs or below you reject. I think you can see very organized work. So let me hope this is the value people have. I'm going to just copy it here. 00423. 00423. Have yeah. May I used to use 5 DPs. Then I get my final answer mark like that. And I get my work done. Okay. I think that has been understood. I don't know, some people have things to say. Yes, Chris, something.
Okay. Where I'm lost is that according to our table, I'm seeing that this value placed it between 2.42 and 2.18. Yet I'm seeing that this value, it was supposed to be between 2.18 and 1.92. I don't know whether I'm the only person who has not understood, because even on your guide, it's what you wrote, but what you have written here, I don't understand it properly.
Oh my days. 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 How can I have over 50 math students? Over 50 math students. And they have manipulated me to that extent. Oh my days. 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 You've said even on the guide it's like that. But that is obvious. Oh my days. Over 50 math students. A, 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 A. Hi, people. You are not easy. A, 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 A. This is supposed to be 1.92. Yeah. Eh, thank you so much. Thank you so much. Thank you so much, sir. Eh, 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 eh. This is 1.92. Thank you. But it is the same explanation, eh? Because values have been in the same position. Thank you so much. You people, 2.17 is between 2.18 and 1.92 because the values are decreasing. I don't know. But sorry about that. It was an oversight. You see how very cheap things can make you do errors? Very cheap. Very cheap. But over 80 math students. But all of you are accepting that 2.17 was between where it was. You people, you aren't serious. Thank you so much. I don't know if you have a number that is active on mobile money. I give you some money. You people, we are now dealing with this. So you people, you see this question? They want you to get f of x. Thank you so much, Chris something. So find f of x when x is 9.508. 9.508. So when you come here, they want f of x when x is 9.508. That means it will be there. So because it will be there, that means we shall encroach the neighbors, and that will be our table. Chris, let me hope this time round we have not made any error. So please, you follow us up. Yes, Akrod.
Excuse me, doctor. The students are complaining that you don't check in the chat. They had raised the concern.
No, but I told you that I need a chat secretary. You people don't think the chat is like a TV. What I'm seeing is the screen. What are they complaining about? Yet we have seen the mistake. You people, when you see a mistake that is so obvious, raise up your hands. When you're too many, like maybe 100 hands, then I'll tell that there is really a problem. But if maybe you think I'm seeing the chat in my palms. I'm not. The chat is verified. Just check it periodically. Maybe when I ask you to say something. So don't complain when you are even giving me answers. Yes, you are unserious. You accept that you are not serious. So that is it. So Akrod, you are the chat secretary. Be active. When something is raised, you raise up your hand. Like 10 people at once, then I'll be like, maybe there has been an error. But if you're just silent, then what do you expect me to do? Okay. So that's what we are going to use, because 9.5 is there. Yes. Between 9 and 10. Hope we are right. So we are going to draw our table. You know, our table is always having 2 rows and 3 columns. Get the point? So I'll come. So they need f of x, isn't it? So I'll come and do that. Do that. Come and do this. Do that. Isn't it? So you all know that what they are looking for is f of x. And they are looking for it when x is 9.508. The x value here is 9. The x value here is 10. The y value here is 2.66. The y value or the f of x value here is 2. Is it 42? Yes, 42, like that. So this time around, I'm going to choose the opposite direction. So people may think that when you use people may think that when you use left right on part A, you maintain the same on part B. It's not a must. They are different tables. So for this table, I can say, now let me face the other side like this. Very okay. Provided as you begin with the f of x because it is your unknown. Yes, so I'm supposed to begin with f of x. So I'll come and say f of x first. F of x first. And because of that direction, it's supposed to be f of x minus this value. So minus 2.66. No other value because of the direction. Out of. So please leave the screen. If you write in the screen again, I'm removing you from the meeting and you will not get back. Please be organized. You're writing in the very space where I'm calculating from. Have discipline. So after that, I'll get the exact x values that are above. The x value above f of x is here. 9.508 minus the x value above 2.6 is here 9 minus 9. Then I'll go this side where I'm supposed to have only and only known values. By known values, that means I'm supposed to focus on this column and this column. You get it? So I'll come and write. Following that direction, that means I'm supposed to have. So people, I'm asking, where am I supposed to have the 10 minus 9? Should the 10 minus 9 be on top or down? 10 minus 9. For the known, 10 minus 9. Is it supposed to be on top or down this side? Just write it in the chat. You see someone is saying on top, another on down. And that's the confusion that really puts people off. You see, someone else has said top. You people don't get confused. Another one has said on top. I don't know what's making people say on top. I don't know what's making people to say on top. People, don't you see that on top we had f of x? That means we should be in this. You get? We should be in this row of f of x. You're supposed to maintain things. So on top we shall have 2.42 minus 2.66. Because on the left we had f of x on top. And we should follow the direction 2.42 minus 2.66. Then down we can have now the 10 minus 9. Why 10 minus 9? We now get the corresponding value on top of each. On top of 2.42, on top of 2.66. Like that. Then after I can rub all these things and make my table clean. But for you not supposed to do it in an exam, your table should be clean, but me I can rub. I don't know if you can also rub. So after that, you use the calculator and get the final answer of f of x. Don't do a lot of steps. That is wasting time. So you're supposed to come, get this, multiply it by this, divide it by this, then add what? 2.66. Because when it goes the other side, it will be what? A positive, like that. So I think people have gotten it. So make sure I get this value. So you just tell me whether it is the value people are getting. The value is here. 2.53808. $2.53808. Is it the same value? Yeah, 53808. Yeah. Like that. So on part B, it's usually 2 marks because they want to award the table once. So they give you a method mark for using gradient and your final answer. When they tell you to round it off or to truncate or whatever to significant figures, decimal places, you know what to do. Yeah. Get your 2 scores. Like that. So how do you confirm that your answer is right? Here we got 11.00 something. That is very clear that between 11 and 12, this value can exist. So you just know you're on the right track because values are increasing. And that value is bigger than 11 but less than 12. So you're right. When you also come to this value, you wanted a value that is between 2.6 and 2.4. And you're getting 2.5. That means if your calculations were very fine, chances are high that even that value is what? Is correct. So that's how you can confirm. Yes, that's how you can confirm that, yeah, I'm on the right track. Okay. Now, that one had techniques. We are going to get back to it later. So you can see that this one is number 6, and it is about root location. It's about root location, which is up next. Yeah, which is up next. Then this one had a technique. We are going to come for it later. So I think even the topic is done, but we have not yet tried out extrapolation. This has been only and only interpolation. So I'm going to come here. Yeah. Interpolation, we have tried our level best. Interpolation, we're just getting values within given values or known values. Nothing much. Nothing much. So I want you people to look at this car value. I want you to look at this car table. We are going to use this variable, okay? They are asking you to get the value of this. What does that mean? It's for share ideas. It's for share ideas. If I'm to go back to this number of mine, yes. They have told you to find it is also a question that usually disturbs people. So let me put here confusing values so that I can confuse you very well. This is what will make you understand. Then these ones are 3, 4, 5, 6, and 7. Then they tell you to find f of 4.5. I want to know, what do they mean? What do they mean? You're going to choose between option A and option B. Then you're going to seek a VO. You're going to see people struggling. So we have started the techniques of the topic. Do they want you to get, do they want you to find x when f of x is 4.5, or they want you to find f of x when x is 4.5? So assuming that's the table that you have, which option does that question want? You see someone has said find x. You see some people are saying find x, other people are saying B, others A. Oh yeah, finding x is A. You can see some people are saying find x, which is A, others are saying B. I think you can see the confusion. Why I always want to give these things time. Because I know they confuse. They confuse. So you people, I don't want you to overthink. I don't want you to overthink. I don't want you to overthink. The thing is like this. F of x, f of x. So whatever they replace x with, provided anything that they put there is x. Anything they put there is x. Anything put there is x. Anything put there is what? Is x. So when they do that, have it in mind that this 4.5 is x. So that means I've already told you that x is what? 4.5. So they want you to find f of x. So it is b. Hope we are together there. So this one is wrong because they cannot be wanting you to get f of x. Why? Where x is supposed to be, they put 4.5. So that means that is a value. That is a value of x. But that only works. I want you to listen. That only works for f of x. Yeah, that's why I've told you that f of x, anything they put there is x. Now, I want to pose another question. You see, with this applied math, you may think you've understood, yet you've not. So that was part A. The part B. What if they tell you to find, because you're also going to come across it. What if they tell you to find the F inverse? What if they tell you to find the F inverse of 3.5? F inverse of 3.5. F inverse of 3.5. Let me see if people have understood. I told you that I always ask you simple questions and you overthink and you end up failing. So what is this one? Is it option A that they want you to find x? If f of x is 3.5, or they want you to find is option B, or they want you to find f of x. If x is 3.5, which is the option? Remember the other one has been what? F of x. So the other one has been f of 4.5. But this one is f inverse. So I need to know which one is it. Which one are people taking? Let me see what's happening in the chat. People are saying A, B, A, B, A, B. People are saying A, people are saying B. You see the confusion? Another one has said B. Hey, another one B, another one A. Hey. Mathematics. Mathematics is very funny. Mathematics is very funny. Another one has said B. Another one saying doctor, it's A. Someone is like none. After confusion, you'd be like, let me say none. Maybe it's me who is right. Another one is lost. Okay. Okay, let me explain. This is the easiest. So first understand this one, and then have it in mind that it only works. Only works. I even mentioned that. I told you that only works. You just don't want to listen to my words. But it only works for f of x. So you people, I want to take you back. I want to take you back a bit. Then you vote again. I want you to vote again. I want you to recall. I want you to recall this. You people have been getting angles in trigonometry, where I always say that sine x is equal to 0.5. Isn't it? This is very important. Sine x is what? 0.5. Then after that, there's a step you always write next. You'd be like, now to get the value of x, our angle, I will say sine inverse of 0.5. I want you to listen. Hey, I want you to listen. Hey, I want you to listen like this. Isn't it what you always say? But remember, this is 0.5 alone. According to this, the 0.5 alone is sine x. Isn't it? 0.5 alone is sine x. Is sine x. Is sine x. Is sine x. What does that mean? And you know that sin x, of course, it is the f of x. It cannot be the value of x. The value of x is only this x, but the whole of sin x is the function. You know that people are getting me. You know that people are getting me. That if you're dealing with angles in trigonometry, and then you be like, my cos x is equal to maybe 0.1. The next step is always x is equal to cos inverse of 0. What? 0.1. But the problem, this 0.1, this one, according to this, from this first thing, the 0.1 alone is cos x. And you all know that cos x is a function in x. You get? So what does that imply? That every time you're given f inverse of anything, that anything is f of x. Are you people understanding? That every time you're given f inverse of anything, what is inside or that anything is the function. That anything is the function, as simple as that. Yeah. So, when you see f inverse of 3.5, this 3.5 is the function f of x. What does that mean? That you've been provided with f of x and they now want you to find x. And this is the hardest thing in this topic. Other things are not hard. So this is wrong and this is correct. So the answer is option A. It's option A. You just need to understand those techniques. You just need to understand those techniques. Mm. So what they want you to find is x. So in summary, when they give you f of 5, have it in mind this 5 is what? Is x. So x is equal to 5. They want you to get f of what? F of x when x is 5, period. That is case 1. Case 2, when they give you f inverse of 5, for the reasons I've given, this 5 is what? The function. So f of x is what? Is 5. And now they want you to get what? X when f of x is 5. As simple as that. So you people, is that okay? Those who are still on, are we together up to that point? Are we together? Let me hope trigonometry has tried to help us at least for the very first time. And me, I believe when I give you the technique, I don't even need to do any number trying to relate with this. It's just obvious. So let me hope people are at the same page. So those two things should never confuse you anymore. But let me tell you, you've understood. You wait for the exam. You will not pass it. You just recall one thing when Dr. Paul was asking whether you've understood. And you recall texting yes in the chat. And now it will be your time to perish. And I assure you, it will perish. That's if you don't practice. Okay. Now you look at this question. So you all know that we are having x in the first row, then f of x down. So when they ask something like this 1.88 is falling somewhere here. You get? Somewhere there. I don't know if you can see it. That is the cat table. And if you can see, this first column is here. This last column is here. Then in between, that's where our value is falling. So I've told you that this one is the value of x. That's why we are having it in the first row. Then down we are having our y. And you know how to do the manipulation. I will not go into that. Then this side, they want the value of x corresponding to f of x 0.4. 0.4, you can see it's falling somewhere here, isn't it? Because those values are decreasing. So this is 0.4 something, this is 0.3. So you can see that this first column is there, last one is here, and then in the middle, the value of fx is the 0.4, then on top you have the x naught. You have the x what? X naught, like that. Then you know how the manipulation is done. Simple as that, not hard. Not hard. I don't even see, the question is here. So you look at this. They asked for f of x when x is 10.15. So 10.15 is between here. X 10.15. It's between 10 and 11. So that's what you do. Then you put your f of x here. But if you're to do like this person, putting here where you're supposed to let, it's better you let and say that let the f of x you're looking for be y, so that they know. Or you leave f of x as we did. After all, it occupies the very first position, then we use a calculator and conclude. Now, for reasons I've explained, when they tell you to find this, have it in mind they are looking for the value of x, and what they have provided is f of x equaling to 2.02. That's why it is in the second row. And identifying is the easiest. Then you manipulate. I don't know whether people are following, but that is it. Then they got the value of x. It's what the array is looking for. Now, this one, trigonometry. Let's see this number. Remember, it's all about you interpreting very well. Look here. They're having a column for x degrees, then for sine x degrees. So they said we want the sine of 40.5. So what they provided is the angle, which is x, and it is falling here, not so? It is 40.5, so it is between 40.4 and 40.8 there. So the value they need is that of sine x. So you may not write the whole of sine x in the table, so you can let it to be y. And I told you that y is the same as f of x. That's why it's what they are preferring here. This one, even if you don't let it, they understand. Y is f of x. And you know it's supposed to occupy this position. Use the calculator and come up with the final what? Final answer. Then when they give you sine inverse, just have it in mind that this one is the sine what? Is the sine x, the function. But you people, trust me, even if you don't know what exactly it is, in case you've forgotten, especially that of the inverse, you can always easily understand. Hey, you ask me how. When they give you such a value 2.02, you come and look at these two. You look at the values of x and those of f of x. Where do you think this value, this value resembles which values? Are they the values of x or the values of f of x? For me, I used this one so that you can first understand. That's why they confused you. I used 2, 3, 4, 5, 6, then 3, 4, 5, 6, 7, intentionally to confuse you guys. But if I had used such values, you people would get things so fast. But in the way that is not okay. So when you look at this 2.02, when you look at these values of x, the 9, the 10, the 11, and 12, then you look at the 2.66, 2.4, 2.18, 1.92. When you look at them, you realize it is them that resemble the 2.02. That means chances are high that this question has provided f of x and it wants us to get x. You get? Then in case you come and look at this one, sine inverse. In case you don't know, or in case you've forgotten what I said, you just look at this value the question has provided, this one. Then go back to the table here. Go back to the table, ask yourself, where is this value really going to fall? You look at the angles, you have 40, 40.4, 0.8, 50.4. Look at the values here down, 0.6, 0. What, 0.65, 0.77. So you just realize that, oh, this value have been given for sure. It's resembling the value of sine x. So you be like, the question has provided sine x and it wants us to get the corresponding value of x. Someone may be like, why are they putting x naught everywhere? X naught, they are doing that because they are trying to show you that it is a root, but we shall see that when you reach that topic. Don't mind. But even if you just put x, it is very okay. Even if you just put x, it is very what? Very okay. So, before I proceed, have people gotten another way you can tell for the things of inverse by just looking at the value and judging where it falls and rectifying where exactly they want you to find the unknown value? Are we together? I want to do an example on linear interpolation. Then you take the very many numbers. Yeah, you just rest a bit, we come back and do root location. But the other time people complained, people were like, but doctor, you're not easy, what? I may decide we take our time because people have been learning interpolation today. It is so surprising. It is really surprising. It is really surprising. It is only physics students who are active. It is only physics students who are active as far as doing work is concerned. I think you've noticed that. But other subjects, I don't know why. I don't know what you trust. For chemistry, it is worse. I don't see anyone doing any mechanism and posting it in the group. Mathematics have been leaving a lot of numbers. No one does. It's only physics students who try to send some wrong answers here and there and we correct them. But the rest, okay. But we are praying for you. Now we are going to first do this number. So you can see that here we are estimating or computing. We are estimating or what? Computing values that lie outside given values. So we are going to do this table. Then I do it on my own. You people may think I don't know these things, but let me show off a bit. Okay. So part B. Let's do some linear extrapolation. It's what I meant. This is something that usually comes most of the time. Yeah. Where are we? You people. I don't know if people are aware we are done with the math syllabus. I don't know. Let me finish this thing and I show you that we are done. Haha. Where are we? Extrapolation. Where is the question? X then x power 3. So the question is x then x power 3. Like this. Then you have x power 3. How many values does it have? Only 3 values. 2.2, 2.6, 3.1. 2.2, 2.6, then 3.1. Then 10.648, 10.648, 10.648, 10.648. Then, where are we? 17.576, 576. Then the last value, 791. 791. 791. I think that is it. 791, yeah. So they are asking us to find 3.4 cubed. Are you seeing this? Find 3.4 cubed. So they are saying find 3.4 cubed. So when someone just looks at those values, you can literally understand that these ones are 3 dp's and these ones are 1 dp. And the value they are provided is to 1 what? 1 dp. However, they can change dp's. So that thing of dp, don't over rely on it. Yeah, you better understand that this one, if I'm to compare it with x power 3, I've been given a value of x period, and they want me to get x cubed. Yeah. So from this, you can really tell that it is x that is 3.4. So they want me to find the x power 3 function. That's what they want us to find. Yeah. So because this may give you a time in the calculation, and if it is a small letter like here, you can let it to be a capital letter. But I told you that sorry is the function, yeah? So they can allow you let it to be y. So let it to be y. So when you look at 3.4, 3.4 is beyond the table. So this is what I talked of, that for extrapolation, yes, we are going to estimate the unknown value, but outside. So 3.4 is coming after this 3.1. That's where 3.4 is. So just like in interpolation where we took on 2 columns on sides, even this time around we shall have to go with this, just like we took the 2 on sides for interpolation. We shall also have to take 2 of them this side. This one and this one, then this one and this one. I know the people are getting it. We are going to see some kind of extrapolation where the value is on the extreme left. This one where it's on the extreme right, I'm supposed to get 2 known columns. For interpolation, because it is between, I take those on sides. For extrapolation, like for this case, it's on the extreme right, I'm supposed to take this nearby 2, the ones that are known. As simple as that. So I'll come and draw my table as usual. My table should have, there's supposed to be 2 rows, 3 columns. So I'll come and do that. Come and put it here. I'll put things here like that. Then I'll come and put here my 2.6, my 3.1, because my value is coming at the end. This one will be 17 point. The person who corrected us in the first example, let me hope we are now doing right things. Hope we are not pissing you off. 29.79. I now don't trust anyone. I'm going to be identifying the values myself, because the last person who gave us values made us flop and kept quiet. This last value, we have said it is 3.4. The value we are actually working for, let me write it in green so that you can easily understand. What are they looking for? X cubed, which we have let to be y, like that. So, the direction to consider, since you want, let me see if you people know what we are dealing with. Remember, y is supposed to occupy the very first position here, like y minus. So if this y is to occupy the very first position, which direction do we follow? Are we following this direction A, or we are following this direction B or N? A. I want you to think well. Don't give me wrong answer. If I really want y to occupy that very first position, am I going to consider the direction A, the direction B, or N? Remember that N was working somewhere, A or none. Is it direction A, direction B, any or none? Yes, it has to be A. I like people who answer like that. It has to be A. The person is like, if it's not A, then I'm changing combination, because that's all my thinking is telling me. So you people, for actually why to begin, it is supposed to be that direction. This other directions will give us other things. So I can now say, let me use this one, y minus 29 point, or I can use the other 17, whichever I want, over, now I come, which value is above y, 3.4, minus, which value is above this one, 3.1. Then I come this side and I'll only put the known values, only the known values, considering that same direction. Yes, so considering that same direction, since on top we had y, Same thing here. On top we shall have these two. Following the same direction, and what will I have? I will have 29.791 minus the 17.576, like that, out of on top of the 29 point something I have there 3.1. I'm going to say 3.1 minus on top of the 17 something I have there 2.6, like that. Hope people know the flow. You people coming up with that table is worth marks. So don't think it's a joke, because it's not easy. You using the gradient stuff, you get the method mark. Then after use a calculator and get the answer. Very easy topic. So you come and get your value of y. And after all, you late, provided you late, even if you don't conclude, even if you stop on y and get the answer. So you get your calculator and press open brackets 3.4 minus 3.1. Immediately open brackets, write that and close. Then you can say divided by, you put that symbol, then you put this, then you say plus 29.79. At once, don't break them down. Just do it at once. And then you get me the answer. Yes, get me the answer. And then you get me the answer. So we are going to take so many questions concerning linear interpolation and extrapolation. So many. That's 7.12. I think you can see that that value is right, because, so let me hope you've not overrounded off. What is the answer? I've forgotten the value. That's 7.12. That's 7.12. Yeah. And you get the answer for the final accuracy mark, A1, like that. B1, M1, then A1, like that. Like that. Yeah. So I think when we come there, you can see that's their answer as well. This one was for extrapolation. It was only one extrapolation was only one answer. Let's do another question. Let's do another question. When it is the other side, when it's the other side. So you can be provided. So you people saw how we can do trigonometry. Let me see if there is any serious question here. This is time and temperature. You can seal in X and Y, people can do. See negatives, log. Many people can manage, but I'm going to talk about a few. If inverse you can, distance you can, the other one is miscellaneous exercise. So I want you people to look at this number. This is exercise assignment, but we are going to do some. Yeah. So that we don't leave any stone unturned. Yeah. Assignment. Look here. It is in 1991. I think 1991 I was 4 years. 1991 I was 4 years. So you look at this number. It's very old, but we cannot take it lightly. We cannot take it lightly. Are you seeing what they want? They gave you this table. Then they said use linear interpolation. So here it was interpolation, and they want you to get this cos 80. Remember, this is cos x. You get the point? So here we are having the 80, then 36 minutes. 36 minutes will be between 30 minutes and 40 minutes. So people are aware that when I do A with the prime, this one is read as A minutes in math, provided you're dealing with angles. No angles have that unit of minutes. Don't forget that. But the problem is, how are people going to do that question? It is a very hard question, though many people ignore it, but it's very serious, because at one moment in time, people cannot deal with minutes. People, okay, who knows how minutes are handled with? Who knows how to handle minutes in trigonometry? Who knows how to handle minutes in trigonometry? Who knows how to handle minutes in trigonometry? Who knows anything? Raise up your hand. I want you to raise up your hand and speak. No one knows? Okay, let me help people. Okay, you ask the internet. People, some of the things when I ask you and you're not sure, just ask the internet. So this is it. This is it. 60 degrees are equal to 1 minute. Like that. But the degrees we are meaning are like this. Okay. Let us do this. You get it? This one is read as minutes. Then this one we read it as degree or degrees. You get? That's it. 60 minutes, 1 degree. Just like you all know. So how can you record it? You can just be like, all I know that 60 minutes are equal to 1 hour. So you'd be like, if at all I'm in trigonometry, 60 minutes, that's how I rate them. They're equal to 1 what? 1 degree. Like that. Hey. So when you're having something like 30 minutes, of course that will be 30 times 1 over 60 degrees, and that's what will give us 0.5 degrees. You get? When you're having something like 45 minutes, that will be 45 times 1 over what? Over 60. And this will give us 3 over 4, which is 0.75 degrees. Isn't it? Hey. Then, I think people are getting it. If it is 15 minutes, that will be 15 times 1. Of course, you'll be getting degrees over 60. This will be a quarter, which is 0.25 degrees, like that. Yeah. 5 degrees, you know what to do. 36 degrees, 48 degrees, you just use a calculator. So I don't know. Is that okay, people? Will you be in position to recall it? Or you just be like, all I know in math or according to time, 60 minutes are equal to 1 hour. Then be like, let me go now to trigonometry. 60 minutes, which are always like that, 6 step prime. I'm talking of 60. They're equal to 1 hour, but this time round, it's 1 degree. You just be like, 60 minutes are equal to 1 degree. Yeah, like that. Hope that makes sense, people. Someone asked where the cube went. It was x cubed, but we let it only be y. So after getting the value of y, you can conclude with the value of x squared. So people, that is very important concerning how minutes are converted. That's if they bring it back. It's a very rare question. That's why it's 1991, but they can set it. They can set it. So this is what I just want to show people. That's what I just want to show people. That when they tell you that that angle is 30 degrees, then they put for you 30 degrees, 30 minutes. You should know what they are meaning. Yeah. So yeah, they are trying to mean that this is 30 degrees. So I'm talking of 30 degrees and 30 minutes. 30 degrees plus 30 minutes, it is 30 times 1 cos over 60 the degrees. That's how you get 30.5. Yeah, 30.5 degree. Like that. You know, if people are getting it, then when they say that is A, then part B, when they say that the angle is 15 degrees and 2 minutes, they're meaning 15 degrees. So the minutes are there to express those small stuffs over this. This one is also in degrees, so they get the answer. I don't know whether it is 15.03333. I can't tell. But let me see. 1 divided by 30. 1 divided by 30. Yeah, it's that. 0 point. I can stop on 3 like that. So that's what degrees mean. So if at all they set it for you like here, you should be knowing what exactly to do. 0 minutes, of course, it is 0 degrees. Like that. Yeah. So when they ask you for this, so you can convert those ones into the degrees if you want. 30 minutes, convert them into degrees. 40 minutes, like that. However, there is a technique of using them as they are. I just wanted you to learn what degrees mean in trigonometry, and I think I'm done. So when they ask you for something like this, are you seeing this? Well, you don't waste a lot of time. Just come here, extract this table. You get, put the minutes there. Draw your normal table. You know, people may think it is something hard. Put there 40 minutes. Put here the 36 minutes in question. Then put here 30 minutes. Put here your values. Then do normal things. Yes, do normal things. Someone may be like, but isn't that really risky? It is not. But what I would advise, the other thing is that if you can convert this into degrees, so that you use that. And with per understanding. Then when they ask you for the cos inverse of this, these are 4 dp's. So you also come to these values of 4 dp's. Find where this value is lying. After that, find out the minute. You understand? So when you put that value, you find yourself getting 18 minutes. But remember, the angle in question is 80 degrees. So you just add there 80 degrees, 18 minutes. How do you understand that it's supposed to be written like that? You look at this first question they asked. They get this angle throughout, that is 80 degrees, and just add the corresponding minutes. So locate this value in the second row, find out the minutes using normal gradient functions. Get them, attach them on the 80 degrees. Then this cheat thing, this is the answer they expect. So I would want to see people trying it out and showing me this answer. I want people to show me this answer coming out. I'm just going to be giving you techniques, nothing much. Okay. Yes, Akro, do you ask very fast because I want us to live here?
Excuse me, doctor. I'm confused
Yes.
somewhere.
Where are you
I'm
confused from?
seeing like they're asking the course things, but in the table we don't have any course.
No, it is here. The question said the table is for cos x. You get?
I have seen.
Mm.
I have.
Yeah, so you are safe, don't worry. Okay, so I'm giving you research, but I'm at least guiding you, so you have a beginning point. And I also want to see my groups of discussion active. So they're asking for the value of degrees Celsius, which is the value of temperature, corresponding to 400 seconds. You understand? So 400 seconds are between that. Because these ones are 360, these ones are 480. So 400 seconds are between there. So you can get the corresponding value of T, which is the same as the corresponding value of degrees Celsius, by using linear interpolation. Then they're asking, determine the time at which temperature is 77. 77 is here, isn't it? Hey, it is between 80 and 75. So you can just use that table and get the value of time here. And your value should be between 120 to 240. So for time, you can just put there, you can say your time will be capital T and temperature will be small t. Whatever you want. You can even say your time will be X and your Y will be the temperature. You can say that your time will be small t and your temperature will be capital T. Whichever you want. You understand? So you can draw new tables. But as I told you, no need of putting those things. If you just draw your table with the 3 columns and 2 rows, if you're looking for time, small t. If you're looking for temperature, the unknown value, capital T. You can use X and Y, provided you let and be like, let the required temperature be this. I told you that. Let the required temperature be that. You can even set it be P. With mathematics, provided you let what you're going to use yourself. Now, this other table is having ln. I've just taught you natural logarithms of recent. Are you seeing this? But it's the same as what we have been doing. When they say find the ln of 1.66, you can realize that 1.66 has replaced the position of x. So that is the thing of x. And you can see it is 2 decimal places, yet values of x at 1 decimal place. That's what I told you, that don't trust decimal places, they can be changed. You should have the real math behind. So 1.66 falls around here. So you cannot fail to get the value of ln x. So it's the value of ln x they want. So this is where you come and say, if you don't want to use ln x in the table, you can say that let my ln x be y. So ln x is the function, yeah? Letting it to be y is the best thing. You get it? Then here they are saying find the value of x corresponding to ln x of 0.4. 0.4 is between here. If you have a very keen eyesight, it is here. Between 0.3 something and 0.4 something, it is here. So you can easily get that value of x they are looking for. You get? They are not hard. So temperature is back with time. So you can see they are telling you that time is capital T in seconds, then this one is theta in degrees Celsius. So if at all you have your table and you're looking for temperature unknown, it should be theta. If at all you're looking for, if you're looking for temperature unknown, theta. Looking for time unknown, it should be capital T, because that's what the question is communicating. So that's what the questions mean. So they are saying value of theta corresponding to T18. 18 is here, between 15 and 20. You get it? Yes, 15 and 20. Okay, then they're asking for the value of capital T when theta is 60. Where is 60? I don't know if people can realize that 60 is here. Yes, theta 60 is between 61.9 and 54.2. You can see it is to 0 dps, but these values are to 1 decimal place. So you should just be steady, and the answers are there. So you can literally follow up and understand everything. Okay? Hey. We proceed now. These ones are negatives. We have not done any number that is a negative, but I believe let us do this one together, number 5. It's having negatives, but negatives mean nothing, provided you have a very keen eyesight. Keen eyesight, keen eyesight, keen eyesight, keen eyesight. We even talk about it as a note. Let me show you that it's nothing. It's even having only and only 3 values. This was negative 1.0, even this was negative 1.0. Then 0.5, 1.4, 0.5, 0.5, 1.4, like that. Here these values don't have order. Anyway, we shall see. 2.2, 3.7, 2.2, 3.7. So according to me, these first values as if they lack an order, but we won't care. Let's see what the question wants. The question is asking for the value of y when x is 0.5. When x is 0.5. People, they're asking for, they are telling us to find y when x is 0.5. Then this side, they're asking us to find x when y is negative 4.5, I think. Let me see. Yeah, exactly. So, I want us to draw these tables together. You know, the tables here is just like that, and when we have the tables, we can progress. Let me begin with this one. It's more obvious. You can see as we move towards this side, the values are becoming more negative. You get? So negative 4.5, it will be outside the table. So I come and put it here, negative 4.5. Remember, I'm looking for that value of x. Then I bring these 2 columns, the ones with known values. Hope you people know that. Negative 1.4, like that. Then this is negative 2.2. Then the negative 3.7, like that. So you people here use the negatives as they are. What is a negative? It is a negative. Treat it like that. But I'm going to brief you. Then here they want the value of y when x is 0.5. Where can we find 0.5? But I think this question, I think they made a mistake. Because here it is increasing. Then here it is decreasing. I think let's make them to decrease. Let's make them to decrease. So let's make this one, let's make them to increase. Okay. Let's make this one 0.4 because we should have a trend 0.4. So they are also increasing, if you can realize. So because of that, that means we shall find, let me even change this question. Let me change that question and say, find that when x may be negative 2.0. So for x to be negative 2.0, I don't know if you can realize, it will be outside here. That's what they call extrapolation. Everything is outside. So this question, we are hitting 2 birds with a single stone. We are having negatives and we are dealing with extrapolation only to the extreme right and to the extreme left. So when they tell you that x is negative, to realize you will find it this side. So I'll have my negative 2 here, 0.0. But what I'm looking for is a y. Then I'll bring these 2 columns, these ones. Yeah. those two. So I'll have negative 1.0, have negative 0.5, then now I have negative 2.2, then I will have negative 1.0 as it is. Those two tables. So this is my table for part A, then this is my table for part B. So now how to do the computations, it is now up to you. It's now up to you. I think we can even just write them below here. We have the space. So if we want really y to begin, the arrow should be like this. And even this side, if we want x to lead, the arrow should be like that. No option. So with extrapolation, the direction is specific. So from here, what will we have? We shall have y minus, I can choose this one and say y minus negative 1 out of, the value above y is negative 2 minus, the value above negative 1 is also negative 1, equal to, what do I have this side? This side I'm having, because of that direction, and this side we should have only knowns, I can now come and consider these two. In that direction, it will be negative 1 minus negative 2.2 out of, on top of negative 1, I'm having negative 1. On top of negative 2.2, I have negative 0. What? 0.5. Like that. Like that. This direction, I'm not going to do it, but I'm going to just say it, and you people will understand. You will have to say x minus negative this over negative 4.5 minus negative this. Then the other side, you'll have only this as the knowns. And because of this direction, what will you have? Negative 1.4 minus negative that over negative 3.7 minus negative that. You get? But this time round, it's a bit different. What do I mean? After you having this, it is better you first rewrite it. This one will become y plus 1. Then this one will become negative 2 plus 1. Then this one will become negative 2 plus what? Sorry, negative 1 plus 2.2 over negative 1 plus 0.5. Then use the calculator. You'd be like this one in bracket times this one in brackets, divide by this one in brackets, minus. Are you seeing this time round? The other time we said plus. But since it's already a plus now, when it goes the other side, it will be minus 1. You get? So someone press things in the calculator and get us the answer here. We see whether it is exactly falling where we want it to fall. Be fast. Negative 2 plus 1 is negative 1. Negative 1 plus 2.2, that is 1.2. Times negative 1, negative 1.2. Negative 1 plus 0.5, what is that? What is that? Is it negative 0.5? I don't know. When you divide, it will be what? Negative 2.4, negative 3.4. I don't know. It's right. Which answer are people getting? Which answer do people get there? Which answer do people get? Hope our calculations are right. Which answer do people get? 1.4. And I think you can see. If y is a positive, then we are doing the needful. Yes, 1.4. 1.4. And it is very right. Very right. This is very right. Because if 1.4 is there, then we are doing the greatest thing. So you do the same thing the other side. Because this one I don't want to do it because I've already tried to show you extrapolation the other side. Yeah. People tell me the value of x you're getting from that. But I don't think people can fail that. The people who are on, you represent the people who will come here in the future. Can you get that value of x on your own? Have you learned how to deal with a negative? Can you get that x on your own? Can you get that x on your own? People, can you get that x on your own? Can you get that x on your own? The people are on. Okay. People are saying they can get x on their own. That is good. That is good if you can get x on your own. Let me hope so. Now you can see this is another question where they are giving you x and log x. X then log x. So they are telling you find log I think log that of 10. But when you look at this 80 is resembling these values of x. That means the question provided the value of x. That is one technique. The other technique, that value of 80 point something is sitting where x is sitting. That means it's the value of x, so they want log. So they're asking the number whose logarithm is this. First and foremost, this value is resembling these values. That means this question wants the value of x because it's even asking the number, and x is the number. For those who studied logarithms with me, I remember telling you when they say log a of b equal to c, so this c is a power, b is the base, and a is the number. So it's like when they ask the number, they're asking for x. So these values they are giving you, this value is resembling the values of log x, so they are asking for x. Simple as that. Now this question is back. I don't know why, but there are people who didn't get this minute thing. But have it in mind, I've given it to you as your research. But it's not hard. They are telling you that x is 60 degrees. So they are giving you 0 minute, 12 minutes, 24 minutes, 36 minutes, 48 minutes. So they are asking for 60, 15 minutes. So 15 minutes fall between here. So if you can convert those minutes into the degrees, then use the degrees. You get? Then they're asking the angle whose secant is this. So you look for this one, interpolation. I think it falls under these two, isn't it? 4-3. 4-3 is falling there. But the best thing, if you really want peace, convert these ones into degrees and use them as degrees. And I taught you how to convert into degrees. And no one will penalize you. No one will penalize you. But remember, you're going to get degrees, and later on you can even convert them back into minutes. But someone may be like, but what if for me I don't want to convert these things into minutes? What can I really do? Let me show you what comes out if you don't convert into minutes. Maybe you love it. Just because some people are always not sure and scared. Let's do only this one. For only those who are scared of converting into minutes. So they're asking for 660. So 60 is a constant. And what is varying are minutes. And we are saying they are between here. They are there. So if we are to draw that table, let me draw it first. So here is it falling 12 and 24 minutes. 12 and 24 minutes. And how many are they? They are 15 minutes. Then 0, 1, 2, 2. 0, 1, 2, 2. 0, 1, 2, 2. Then 0, 2, 4, 5. 0, 2, 4, 5. Okay. And then here they said 15 minutes. So you can be like, I told you that here it's okay to put y provided it's your function, because our function is sec x. So you can put there y. So I want to show you what really happens if you just treat those minutes the way they are. You may not get the right answer. Yeah, let me show you. So using any direction, let's assume we are taking on this. So I believe now your pros, we are just testing. So what if you come and say this minus this? I want you to be very fast. This one will be 15 minutes minus 12 minutes. Then this side. This side we must have only nouns. So I'll bring this 245 minus 20122. It's even midnight. You're supposed to be out of here 12 minutes. So you get the answer. So someone may be like, but how should I press minutes in the calculator? Just press them as normal values and tell me the value you get. Yes, the good thing the book has some answers. I want to show you what happens if at all you don't convert. Because I know you not even do the research work, so you better do it together. 0, 1 to 2. 8 by 12 times 3 plus 2.01 to 2. Which answer people getting? That answer is not correct, Chimbugwe. People, you cannot give me an answer that is exponential. You be serious. Then Raj, that answer is correct. It's what I also have here. So we are getting 2.01528. You now use 5 dps, 28. But look at the answer they have here. Are you seeing? Are you seeing the answer they are having here? It is 2.0307. You understand? That means our answer is not correct. Someone may be like, where are we? I don't know why the answer is like that. That answer is also not correct. But the best thing, my advice would be if we could convert these angles into degrees. There are some questions during practice, but it was back then. There are questions which give you the exact answers because you're just converting. It's like in physics or in mechanics. Provided you maintain the unit, even if it's not the SI unit, you get the same answer. I know that people know that. So I don't want you to be surprised when we get the same answer, slightly the same answer. Don't be surprised. Yeah. I just want us to appreciate. So you know that this one will be 12 over 60. And this one's supposed to be degrees. You get even this one's the 15 over 60. And this one's supposed to be degrees. Even here, 24 over 60. And this one's supposed to be degrees. There are questions that are stubborn. They can give you very weird, different answers. Yeah. That's why this is a rare case. Yeah. But you don't need to be worried. So we have 12 divided by 60. which gives us 0.2. So this one is 0.2 degrees. Are you following? Then we come 15 divided by 60, which is 0.25 degrees. Then we are having 24 divided by 60, which is 0.4 degrees. Someone may be like, why are you getting those degrees? When you go back to the question, we have this angle of 60, which is a constant. You get? That angle of 60 is a constant. That means 60 degrees and 12 minutes is the same as what? 60.2 degrees. I taught you how to convert. Then this one will be 60.25 degrees. Then this one will be 60.4 degrees, like that. Yeah, in case you're just using angles. So now you repeat. You come and be like, so you're going to go back to the calculator. So instead of 15, we are going to put 60.25. Instead of 12, we are going to put 60 point what? 0.2 degrees. Instead of 24, we are going to put 60.4 degrees. Then instead of this one, we shall put 60.2 degrees. Yeah. Yeah. Now you people, you get the answer. You get the answer. So you realize you will have even a different table. Minutes may look weird to be used, but if at all you convert it into degrees, it is very okay. But as I've told you, there are questions that will give you the same answer. There are those that will give you slightly the same answer. There are those that will give you weirdly different answers. But you'll never recognize that if you don't practice. Yes, you'll never see that if you don't practice. This is 60.25 minus, this is 60.2. 60.2, you get that, divided by 0.2. Then we add on to 0.0122. Do you see that we are getting the same answer? Do you see that we are getting the same answer? Exactly. Now let us make a note. I wanted us to prove it on our own. So you get this from me, note. Note. For trig, use of minutes is the cheapest and easiest. Someone can decide to convert. This one takes time and you can make errors. So you people choose wisely. Just choose wisely. Yeah, just choose wisely. But as you progress, let me tell you, for the case of trig, let's now just take it that no problem. Whether the person has used minutes, whether the person has converted, let's just take things on like that. Someone may be like, really, why? Why is it like that? These ones are both have it in mind that the minutes and degrees both are units of angles. So it is very okay. So with mathematics, I don't want you to cram things like the teacher told us this, the teacher told us this. In most cases, you're supposed to do what I've done. We have dealt with minutes and we have seen the answer. So just like the same way I've been using degrees, how? We have not bothered about this degree and we have not pressed it in the calculator. we have been just putting 60.2, 60.4. It's the same thing we did, it's the same way we did with minutes. If we just put what? We just put the 15, the 12, the 24, and 12 without bothering about the unit. After all, both are degrees that measure angles in trigonometry. Even when they bring radians, for you don't mind, just use it as the way it is. So that means even when they ask you for this question, so when they ask you for this one, what you'll get will be a minute. Yes, and you get a very good value. Then you attach it to 60. Yes, as you can see there. So I told you that covered this one, 2.0436. It will fall between here. Now when you put it there, for in your calculation, you should put the minute and the minute. You get? Then trust me, the answer you're going to get here will be 42 minutes. But since they want the overall angle, you come and write it like this. Yes, you write it like this. So you come and say now, since I've obtained my answer as 42 minutes, the overall angle is 60 degrees, 42 minutes. So one thing you've learned today at least, that minutes and degrees, just use any that you want. But also learn how they are converted. Yeah. But I remember there is a question, but I think no. I think the question had an issue. But it was back then. But what I can tell you as of now and forever, minutes, degrees, they are units. They are different units, but both of them measure angles in trigonometry. So whether you've used minutes, whether you use degrees, you get the same answer. So converting may not overhaul. Just like I said, just like in math and physics and chemistry, if I told you don't convert to SI units, but maintain something, you get the same result. So it's the same thing that has happened here. So don't overthink. Okay? So this one, we try to do it. So those ones, I just believe they are obvious. This is distance. This is distance and fuel. Distance, now you can give it letter D, then fuel letter F. Yes. Or since fuel is in liters, you can give it letter V. Like that. You find ways. So yeah, they were asking for how far, that is distance. When you have used this fuel, then yeah, they're asking for fuel for this distance, and the answers are here. So you can confirm. Then yeah, they're having T and F of T, just like X and F of X. So those ones are also obvious. Mass, you can use M. Charge, you can use letter C. Like that. Yeah, they're having distance is X and cost is Y, so use X and Y. Yeah, they're having X and F of X. What usually makes these things hard are the quantities they have used. This one is X and Y, obvious. This is X and F of X. Yeah, I think we are done. This one is also X and F of X. This one is capital T and capital S, just like the way they use capital Y and capital. You get? Distance and fares. You can even use this one as your X, this one as your Y. Better. X and Y. But all you don't have options. Then this one is just miscellaneous exercise 2, just a continuation, meaning that in the first exercise, all things have been tampered with. So I just think everything is okay with you. The only thing I may expect to be disturbing is the thing of minutes and degrees. But I think you now have the liberty to use the minutes the way they are, then use them like normal angles. Or you do it like normal stuff. And even here, I'd explain to you. Yeah. They had asked for 36 minutes. So put them there, put the value here, put the value here, get your value here. So minutes are just like the way you call money. Like this is 2,000 shillings. You don't focus on the shillings when you're pressing on the calculator. You just put in the amount. So that's the same way you should treat minutes. But also don't forget the mathematics behind them. So when I go back here to our syllabus, I think we have concluded this. So instead of the session I was going to have with you to cover part of root location, I'll cover root location as a whole at once. So reviewing, we got done, and even this part B. So this is a bye-bye to that first subtopic. So we shall have 3 lessons. The second will be for that. The third will be for this. However, this last one may have 3 or 4. That's what I said. But root location, the next time we meet, she'll be done. It will be done. Don't worry. Yeah. I think that is it. Yeah. Thank you for listening, people. Now time for taking screenshots of the assignment. Screenshots of the assignment. You first take that. That is 1. As you're taking screenshots, you tell me in the chat whether you give me a percentage of the success of the lesson, whether it has been 10% success, 20% success, 30, 40, 50, 60%, 70, 80, 90%, or 100% a success. If it's 100%, that means you have also understood the minute thing degree. Okay. You give the lesson a percentage to which it has been a success. You also take that after you share these things with your friends. Actually, this is the first topic where we have tried to go through each of the numbers of the exercise, and I think you will pass them. Okay, you take that. As you give the lesson the percentage of success, take that. I post in the group, you take that. Take that. At miscellaneous exercise, trust me, you don't need it. Don't need it. Take that one. It is very easy. Just look at theta, sine 10, what, f, distance, force, table, what. Very easy stuff. Then lastly, take that one. Can see very easy. Just having a lot of numbers. Linear interpolation is coming back in the next topic, and it's also there in Newton-Raphson. Realize here, according to the syllabus, there is here what we call further linear interpolation. That's why I had to invest a lot of time and make sure you understand, because the one that is further is a bit serious. Yeah. The answers are also there. For the miscellaneous. So also take that screenshot and send to the friends in the group. Hope you people are done. So that is the end. It is the end. Hope people have rated the class. So I think I can also sign out. So I'm going to upload the math lesson, this very one, and the physics lesson we had in the morning, lesson 2 of circular motion, because people have been asking for it. So allow me sign out. Sport tutor, science math tutor, Science Scholars Academy based in Uganda. That is my personal number for Immediate faster response. Can always give me WhatsApp call. If I don't pick, you just know I'm in class, period. Because I teach science subjects. So chances are high that I'm always occupied. Let me go through people's comments, then I leave this place. Yeah, I'm going to put the PDF on the drive, I think. Hey, where did this comment start from? Okay, please, people, thanks for attending. So make sure you practice. You know the strategy of math. First, repeat the examples I've done. Then you can now attack the exercise. If there is research, you do the needful. You do the what? The needful. Simple as that. Those who want to use minutes as they are, use minutes as they are. Those who want to convert minutes to degrees, do the same. I think we covered both alternatives. Yes, so you choose what you want. Just practice and do like 3 numbers and repeat those ones we did on your own. Look at your solutions, post them in the discussion group. If they are confirmed by me, you just know that here now I'm on the right track. In case you've been disturbed by any concept I've talked about today, immediately after this lesson, those who have stayed on, you give me a call immediately so that before you sleep, we resolve it. So let me share the workbook of morning and this very one. Then I also share the previous ones. Yeah. Otherwise, thanks for listening. Have a good night and bye-bye.